Hi, my name is Lornavine, and I'm from Harmony Science Academy-Euless. My project discusses the effects of sodium chloride on seed growth through the use of a bioassay test. A bioassay test is one in which an organism is kept under laboratory conditions and exposed to various quantities of a specific chemical. This is crucial for assessing potential environmental threats. With this knowledge, we will be able to identify the specific conditions under which plant thrives and determine what we need to do to prevent anything from interfering with this process. Understanding the fundamentals of plant growth will lead to significant breakthroughs in plant physiology and lead to a thriving environment. A large percentage of crop failures is caused by an increased sodium chloride concentration in agriculture. Because of the high levels of sodium chloride in agricultural water, a considerable portion of the land is deemed unsuitable for crop production. This research can help to better understand and improve crop management, maintain sustainable agriculture, conserve the environment, and ensure global food security. Understanding the salt tolerance of specific plants can aid in the development of sustainable agricultural land to ensure food security. Global food security is essential for survival as access to nutritious food has numerous benefits in our lives. The primary goal of this experiment is to help farmers maximize irrigation operations and alter the way they maintain their land. A substantial portion of the world's land is deemed unfit for crop and agricultural use, but insight and knowledge gained from this experiment can help build a solid basis to counteract the detrimental impacts of sodium chloride in our ecosystem. Understanding the effects of sodium chloride on seed germination is crucial because due to its broad implications across various fields of science. Sodium chloride hindered seed germination by impeding the absorption of essential nutrients. This research aims to optimize irrigation systems, improve policies and regulations, explore genetic modification, and much more. Its potential impact spans revolutionizing agriculture and ensuring global food security while promoting sustainable agricultural land practices. Investigations of the detrimental effects of sodium chloride concentrations in Lactica sativa growth is pivotal for advancing our understanding of fundamental biological processes. These are some pictures taken during the experiment. The first and second images are of the seeds after the germination process, and the third image is the extraction of the seed from the petri dish. The first image is shown is during the measurement of the embryonic root. The second image is the control petri dish, and the last image is the zero point 0.1 concentration petri dish. As you can see by the images, the control variable had a lot more embryonic root germination compared to the other variables. While completing this experiment, 4 different amounts of sodium chloride were used. Control, which had no sodium chloride, zero point 0.5 moles of sodium chloride per liter of solution, zero point 0.1 moles, zero point 0.2 moles, and the control variable. After exact measurements, which is 2 mLs of each concentration, were poured into each petri dish and left in a dark, moisture-retaining environment for a 5-day period. After removing the petri dishes from the original location, the radical length of each differed greatly. No growth was observed in the 0.2 m petri dish due to the high concentration. However, the 0.05 m petri dish showed considerable embryonic root germination. The findings of this experiment indicate that the lower the concentration of the sodium chloride in the water, the greater the amount of embryonic root germination. The hypothesis established at the beginning of this experiment has been confirmed based on the results and observations made throughout the course of this research. In the future, I'd like to repeat this experiment with different seeds, perhaps salt-tolerant vegetables such as tomatoes. Based on outcomes and data gathered throughout my investigation, it is reasonable to conclude that sodium chloride has a number of unfavorable consequences on embryonic seed germination. Thanks for watching HSA-Euless.